Hello and welcome to this video. Today we're going to be talking about how to go through problem number 14 of Quest homework number 2. So here's the problem up here. A motor is traveling at 11 meters per second, encounters a deer in the road 45 meters ahead. If the maximum acceleration that the brakes are capable of is negative 7 meters per second squared, what's the maximum reaction time of the motors that will allow him or her to avoid hitting the deer? Answer in seconds. Okay, so this is the problem we're working with. And here's the little picture we have. So there's the car, you have this reaction distance and this braking distance, and here's the deer. So I'm just gonna start putting some labels in here. I'm just gonna call this total distance, delta x, and put a little t underneath it down there. I'm going to call this distance, braking distance, delta x with lowercase b, b for braking. And then I'm going to say, let's do yellow, this is the reaction distance. And I'm going to say delta x, r. Okay, and now let's see what we know. Okay, let's see what we know here. Let's just write some knowns. I'll do it in black. Motor traveling 11 meters per second. So we know V initial is 11 meters per second. And that is both here before you start reacting and here before you start braking, because nothing's changing while you're reacting. That's when your brain is processing the stimulus and sending a message to your foot, hey, it's time to hit the brakes. So if V initial is 11 meters per second, we know that delta X total is 45 meters. That's because that's the distance from where he is to where the deer is, so that's delta x total. We know that the acceleration, when you're braking, the acceleration is going to be negative 7 meters per second squared. What's maximum reaction time? And what the main question is asking us is what is, I'm going to call it T sub r. What is this reaction time here? That's what the main question is asking us. But there's also something else that we know. You're going to avoid hitting the deer. You're going to avoid hitting this deer. So we can assume also that we have, I'm going to say V final. And this is, since it's pink, it's the braking distance final equals 0 meters per second. I'm also going to notate it up here, this V final. All right, that's 0 meters per second. Okay, let's see what else that we have. Do we have enough information? We do. We have 3 pieces of information, 1, 2, and 3. And what we need to solve for is this delta x. We're trying to solve for delta x, b. We don't know what this is, and we also don't know what this is. We'll need this delta x r later. We're trying to solve for delta xb. What's lucky is that we have an equation for this. We can say, let's see, we know that delta x, we have our equation chart up at the top. Delta x equals VIT plus 1/2 AT squared. Now, is this going to work? It's not going to work because we don't have time. Okay, let's try another one. Let's look at final velocity squared equals initial velocity squared plus 2a delta x, and put a little b down here so it's braking. Does this work? We know velocity, final, we know the initial velocity, we know the acceleration, and we're trying to find the braking distance. So that does work. Okay, so let's rearrange that equation. Let's say delta x b. We can write that equals v final squared minus v initial squared over 2a. And now we can plug in numbers. V final squared is 0 squared. Minus, we know v initial squared is 11 meters per second squared over 2, and we know that our acceleration is -7 meters per second squared. So we can put all of that together, and we know that delta x sub b, or our braking distance, is going to be, let me get a calculator here. I get 8.64 meters. And it's always good to double check your work and check your units. Okay, looks like that's right. 11 squared over 2 times 7 gives me 64 meters. And this is for Quest, so you're going to want to carry out more decimal places and use your numbers since they'll be different. Okay, so now we know this is 8.64 meters. So we go ahead and add that to our drawing. Therefore, we know we can also figure out what delta XR is. We know that delta XR is the total distance. Let me do better about color coding. Is this total distance minus the braking distance, which means that delta XR so equals 45 meters minus 8.64 meters. So we know that delta XR then must be 45 minus 8.64, 36.36 meters. Okay, so we have that answer now. So now comes how fast does he travel? And how long does it take? So let me do green for this, or blue for this one. So we know that he's not accelerating. He hasn't realized the deer's there yet, and he hasn't started to push the brake pedal during that reaction time. So we can say that this velocity, this initial velocity, is just the displacement, or delta x sub r, over the reaction time, or the change in time. So we can rearrange this. We can therefore say the reaction time, T sub r, is equal to the displacement, or delta x sub r, over the velocity that you're traveling, which equals, let me move my toolbar, by the way, that equals 36.36 meters over 11 meters per second. And you'll notice that the units work out, so these meters cancel and the seconds goes up to the top. This means, therefore, the reaction time, T sub r, must equal 3.305 seconds. And you'll want to be a little more precise when you're plugging this into Quest, but 3.305 seconds, and you got your answer. And there you have it. That's how you find the reaction time required for him to not hit the deer, or her to not hit the deer. We're going to be doing number 15 in the next video, so make sure you check that out. Later.